Hello students, welcome to day 5 of our 100 days mathematical conceptual learning challenge. Today we'll revise all the formulas that we have discussed in the last 4 days, and also we will be dealing with some interesting facts on triangles. So let's begin with the first concept, that is our scalene triangle. So what is scalene triangle? A scalene triangle has all three sides of different length. So here we have three sides, that is A, B and C of different length. So in a scalene triangle, the first basic thing was to find this S, which was called semi-perimeter. Semi-perimeter was nothing but the half of the perimeter. Okay. And what was the perimeter here? Perimeter is the sum of the length of the boundary. So A plus B plus C divided by 2. Now you will use this as in the formula of a scalene triangle. What is formula? Area equal to under root S minus A, S minus B and S minus C. Okay. Use this formula to find the area of an scalene triangle. You can use this formula on any triangle if you know the three sides of the triangle. Next, area of isosceles triangle. Area of isosceles triangle was b by 4 under root 4a square minus b square. What was our a and what was our b? A was our equal sides, length of equal sides. Okay, a is nothing but the length of equal sides. And b was length of unequal side. Length of unequal side. Okay, so we can use the formula b by 4 under root 4a square minus b square to find the area of an isosceles triangle. If you want to find the perimeter of the isosceles triangle, you can use the formula 2a plus b. You don't have to use the formula, just add the length of all the three sides. Now coming to the height of an isosceles triangle, we have derived this formula and we know how this formula has come. Okay, so formula is 1 by 2 under root 4a square minus b square. Now the next triangle is equilateral triangle. Area of an equilateral triangle is root 3 by 4 a square. What is a? A is nothing but the length of the side. Length of side. Okay, so if you know the length of the sides of equilateral triangle, use the formula root 3 by 4 a square to find the area of triangle. Perimeter can be easily found. You know the length of one side is a. Since all the sides are equal, we can say 3 into a. That means perimeter is nothing but 3 into a, that is 3a. Now, right angle triangle. In right angle triangle, we use the formula half into base into height. That means always remember the angle between height and the base is always 90 degree. Okay. Whenever you know base and the height of any triangle, you can use the formula half into base into height to find the area of triangle. Not only in the case of this, if you know, but always remember about the height. Height, or you can say altitude, these are perpendicular to base. Okay. Now, let's discuss some important facts related to triangle. First is, sum of the length of any two sides will always be greater than the third side. If it's not, then such triangles are not possible. See, let me take a triangle whose sides are given as A, B and C. The A, B and C are the length of the triangle, sides of triangle. Now, if you add any two sides, suppose if I add A and B, that is A plus B, this should be greater than C. If I add A plus C, then this should be greater than the another side, that is B. If it is B plus C, if I am adding the side length of the side B and C, then it should be greater than A. Okay. Let me take one example, one question. Suppose it is 10, 12 and 23. Now if I ask you whether such type of triangle is possible or not, let me check. First one is 10 plus 23, that is equal to 33. 33 is greater than, that is the left side, that is 12. Okay. Now if I add 12 plus 23, it is equal to 35, which is greater than 10. But what if I add 10 plus 12, which is equal to 22? Sorry, 22. Which is less than 23, which is wrong. First one is correct, second one is correct, but third condition does not satisfy. That's why we can say such type of triangle is not possible. Next, sum of interior angles of any triangle is equal to 180 degree. Yes, if you add the interior angles of the triangle, suppose this is x degree, this is y degree, and this is z degree, then x degree plus y plus z, sum of these three angles should always be equal to 180 degree. Then only we can say it is a triangle. Okay. Now, the measure of an exterior angle of triangle is equal to the sum of measures of two interior angles that are not adjacent to it. See, this is an exterior angle. Okay, so this is D. So D is equal to sum of two interior angles that are not adjacent to it. So we can see A and C, they are opposite angles and they are not adjacent. So we can say D equal to A plus C. If I give you one question and I ask you what is the value of x, then x will be equal to sum of C and sum of B. Okay. Got the point? So always remember, the exterior angle of triangle is equal to sum of measures of two interior angles that are not adjacent to it. Sum of measure of three exterior angles, one for each vertex of any triangle, is 360 degree. What is the meaning of this? Let us take an example. We have a triangle whose angles are given. Let me take the angle as 50 degree, 60 degree and 70 degree. Now if you see, the angle will be, I ask you what is the value of this, you will say, sir, 180 minus 70, this is 110 degree, because the complete angle is 180 degree. So I got this value as 110 degree. If I ask you what is the value of this, you will say 50 degree will be subtracted from 180 and that will give you 130 degree. Now, if I ask you what is the value of this, you will be telling that 180 minus 60, that is 120. Now if we add 110 degree plus 130 degree and 120 degree, you will get 360 degree. Okay, so the three exterior angles will always give 360 degree for any triangle. Okay. Next question. Area of any triangle is equal to half the product of its base and height. I have already discussed that if you know base and height of any triangle, that means base and height, then area can be easily calculated. Area equal to nothing but half of product of base and height. That's what the formula was. Area equal to half into base into height. Next, when you will study trigonometry in the later class, you will come to know trigonometry is nothing but the study of relationship between the angles of the triangle and their sides. Okay. So in trigonometry, we study generally the relationship between the angles of triangle and their sides. Okay. You must have heard few words like sine theta, cos theta, tan theta, and so on. See, sine theta is nothing but the perpendicular divided by hypotenuse. Cos theta is base by hypotenuse. And tan theta is perpendicular by base. In this way, you see trigonometric ratios are just the ratios of their sides of the triangle. Okay. I'm just giving the examples. These are the only few concepts related to trigonometry. There are many which you will come to know in the higher classes. But right now I'm just giving example. You don't have to focus much on this example. I'm just telling that how the triangle is important. The triangle is very important in case of trigonometry also. Okay. Now coming to the another point, that is triangle shape are often used in construction because of their great strength. Always remember, the triangle shapes are the more stable, okay, and have more strength. Okay, so triangular shapes are more stable and have more strength. Now, some important facts related to triangle we can study is orthocenter. What do you mean by orthocenter? See, orthocenter is nothing but the intersection of altitudes. Intersection point of all three altitudes of triangle. Okay, that means three altitudes of triangle will meet at a common point, and this point will be called as orthocenter. So if anybody asks you what do you mean by orthocenter, tell them orthocenter is the intersection, meeting point of all the three altitudes of triangle. Now always remember, altitudes are perpendicular to the base. Okay, you can see here altitudes are drawn perpendicular and it has been joined to the opposite vertex. So this is your one of the altitudes. Okay, this is altitude to this side. In this way, they have drawn three altitudes and they have met at one common point, and that is called the orthocenter. The three lines from each vertex to the midpoint of the opposite sides also meet at a common point called centroid of the triangle. See, centroid is nothing but the intersection point of all three medians of the medians of triangle. Now you will ask me, sir, what is the meaning of the median? See, in simple language we can say median is the midpoint. Okay, median is the line that joins midpoint of a side to the opposite vertex. See, suppose I take a triangle A, B and C. I have drawn a midpoint D here. Okay, I have drawn a midpoint. Now I will connect this midpoint to the opposite vertex. This line is called median. Okay, in this way you will be able to draw three medians. Two more medians you can draw. See, take the midpoint of A and C. Suppose I take the midpoint as E, and now I will join it to opposite vertex B. Okay, now on AB also I take a midpoint F, and I will join it to opposite vertex C. You will get one intersection point, and you can compare from here also. All the three medians are intersecting at one point, and this is only you can call as centroid. Centroid is a point of intersection of all the three medians. Okay, and what is medians we have discussed right now. Circumcenter. See, in circumcenter is the intersection point of all three perpendicular bisectors of triangle. See, perpendicular bisectors of triangle. Now, if you read the definition, the lines that pass through the midpoint of each side and is perpendicular to the side that is perpendicular bisector also meet at a common point called the circumcenter of the triangle. That means circumcenter is the point of intersection where all the three perpendicular bisectors meet. Now you will ask me, sir, what is the meaning of this perpendicular bisector? Okay, see, there are two words involved here. One is perpendicular and another is bisector. Okay, now what is the meaning of perpendicular? That means it is 90 degree. And what is the bisector? It means it divides into two parts. So if I draw a point, that means you can see bisectors of side. So suppose, let me take one example. I have taken a triangle A, B and C. On BC, I have drawn a midpoint. Okay, and suppose the midpoint name is D. Here I have drawn a perpendicular, that is 90 degree, and not joining it to the vertex. I'm just opposite. I'm not joining this midpoint to the opposite vertex. I'm not joining it to anything. I have found the midpoint of BC as D, and there I have drawn a perpendicular. So you can see I have drawn a perpendicular. In the similar way, on AB, I have found another midpoint E, and here I have drawn a perpendicular. Okay, midpoint always divides the side into two parts. Always remember. Okay. Now, on AC, I have drawn a midpoint F and drawn a perpendicular to AC. Now you can see all these three perpendicular bisectors are meeting at one common point, and that is called your orthocenter. Orthocenter. So orthocenter is nothing but the intersection point of all the three perpendicular bisectors. Remember this two words of triangle. Now, the orthocenter, centroid and the circumcenter of a triangle lie on a straight line. This line is called the Euler line. Now, what is Euler line? Euler line is that line where you can see orthocenter, centroid and circumcenter on a single line. In another word, we can say that orthocenter, centroid and circumcenter center. These three centers lie on a straight line. Lie on a straight line. Straight line. You can see these 3 points are lying on a single line. And this line is called as Euler line. Euler line. So question can be asked in any way. What is a Euler line? So you can say in Euler on Euler line contains orthocenter, centroid and circumcenter of a triangle on a straight line. Or they can ask you whether orthocenter, centroid and circumcenter lie in a single line. You will say yes, they lie on a straight line. Okay? Two triangles are similar if every angle of one triangle has same measure as corresponding angles in one triangle. See, this is half correct, and this will complete the second point, will complete that concept. But what's the meaning of similarity first? See, let me take one example. I said this triangle has some measurement. Let me take the measurement. This as 50 degree. This also 50 degree. This as 70 degree. This also 70 degree. And this as your 60 degree. So this will also be 60 degree. Okay. Now, you can see I have drawn two triangles, but they are not of the same size. Their angles are same. That means their angles are same, but size are different. In another way, we can say shape is same, but size is different. They have same shape. Both are triangles. Both have the same angle, but different size. Okay. So in similarity, first concept is angles are same, but sides, length of the sides are different. Or in other way, you can say we have the same shape, but different size. Okay. Now, the second point tells us that the corresponding sides of similar triangles have length that are in the same proportion, and this property is sufficient to establish similarity. Now, what is the meaning of that? See, if I take this as a 5 unit, this as 10 unit, okay, and this as your 12 unit. I have another triangle, same, angles are same. I take as a 10 unit, this as a 20 unit, and this as 24 unit. Now you can see this is 5 unit, but this is 10 units. How many times? It is 2 times. This is 10 units, this is 20 units. That means they are corresponding sides. How many times? 2 times. This is 12 and this is 24. How many times? 2 times. That means this triangle is double of this. Yes or no? So we can say they are similar because angles are same and their sides are in proportion. They are double of them. If one is 1, then another is 2. That's just a double the size, right or no? Okay? Now, more concept related to the similarity you will be learn in the higher class. Okay? Next. Congruent triangles have exactly same shape and same size and shape. So, in similarity, what you have learned? You have learned that they have the same shape but different size. But in congruency, you will be seeing that we should have same size as well as same shape as well. Or you can say same shape and size. So how? Let's see. If I take one triangle and compare with the other triangle and they are congruent or not. That means congruency means congruent triangles are equal in every aspect. Congruent triangles are equal in every aspect, in every way. So you can see here, if I take this as a 50 degree, then this will also be 50 degree. Now let me see. If this is 60 degree, I am taking this as a 60 degree and this is 70 degree. Sorry, yes, 70 degree. This will also be 70 degree. Now, we have got the same angles. It is a triangle, same angles. That means we have got the same shape. Now, if this is 5 unit, this should also be 5 unit. If it is 10 unit, this should also be 10 unit. If it is 12 unit, this should also be 12 unit. They should be exactly same. Exactly same. Then we can say two triangles are congruent. Now you can see we have three pair of pair of corresponding interior angles. That means we have three pairs of angles and three pairs of sides. When you will study in the higher class, you will come to know out of 6 equalities, we need only 3 to prove the congruency. Okay, that we will study in the higher class. So thank you. This was all from the today's session. If you have any doubts related to triangle, you can write in the comment box and we will deal with in the next session. Okay. Thank you so much for attending this session. See you in the next session. Thank you.